Hello, everyone. Hello and welcome to another one of our much anticipated online sessions, actually. We've had this one in the diary for a little while, and it's been very popular. Lots of registrations. It's always the same, actually, when it's a nice interactive session. And I think today is going to have some really good takeaways for everybody that's joining. In terms of that, obviously today's session, how to build a RAG-powered chatbot to answer HR questions. It's with our partner Superlinked. It's been awesome working with Superlinked actually over the last, 6 months plus actually, that they spoke a couple of conferences ago. This most recent May Day conference, they came as a gold sponsor and exhibited, again, came with some great content and now delivering, as I say, very interactive webinar. And the thing I love very much about Superlinked is they are definitely very community minded, and they've had some great ideas for this session. So in terms of today's session, if I could ask Mór just to turn on his camera and microphone. Mór's a lead ML engineer at Superlinked and will be the person delivering the session today. We're really lucky to also have Harshil and Ben in the back end, keeping an eye on the chat, answering your questions as we're going. So as I say, interactive session, so don't be shy about saying hello and talking with the team. In terms of Superlinked, obviously Mór's going to tell you a lot more, but super high level overview. Superlinked to the data engineer solution to turning data into vector embeddings. There is a lot going on. These guys are moving quick. They're growing. So we're really lucky to have them with us today and delivering today's session. So what I'm going to do, Mór, I'll just stop sharing my screen for a second and get you to share yours. There'll be a few bits going in the chat. I'll just double check where they are already. While we're waiting for that, everyone, feel free to say hello. Let us know where you're joining from. It's always nice to get a little bit of community vibes at the same time while we're hosting these things with everyone out there in the world. So let's have a little look. So hopping off the chat, bear with, let's have a go. There's messages coming in. So Harshil, hello from London. Yes, Harshil, we couldn't do it without you, man. Naya, perfect. Joining from Manila, welcome. Bangalore, another from London. Greece, London. Abhishek, hello. Thanks for giving me a little shout out there, mate. Love that. Georgina from Milton Keynes. That's where I'm based. So yeah, lovely to see you, Georgina. It's going. We've got a good crowd for you, Mór. So if you're happy, I'll maybe hand over to you. Feel free, as I say, to put some more links in the chat, put the competition in the chat, give that a little plug. But if you're happy, I'll maybe hand over to you, Mór. Are you happy with everything?
Yes. Thank you, David, for the kind words and the introduction as well. I can start.
Amazing stuff. In terms of that, obviously, we're seeing your PowerPoint at the moment, not in presentation mode. Are you happy with that, or would you prefer to go full screen?
I like this because this way we can
see where you are. I like this. A seasoned pro, man. A seasoned pro. Well, have a great session. Like everyone else, I'll be watching along in the background, and I'll catch up with you towards the end as we go into any Q&A and stuff like that. But have a great session.
Thank you very much again, David. So, hello everyone. I'm really happy that you joined. I really appreciate your time taking to listen to our webinar. So let's not take any more of your time and dive into the details. So I'm the lead machine learning engineer of Superlinked, and today I'm going to talk about how to build a REX or retrieval augmented generation based chatbot on a dataset that has numbers. And I'm trying to explain why numbers is a thing. So why we are talking about this, why is that even important? And when I talk about RAG, I talk about a lot of things, obviously, but I think above all, I'm talking about semantic search. And if you only check semantic search through Hugging Face examples like this one in the slide, it might seem like that semantic search is pretty easy, like finding a match for that is a happy person from these three seems quite obvious, but in real life, things are just not that easy. And in order to show that, we listed some of the queries we face during semantic search in our use cases that we do. And if you look at these queries, these seem, I think, a tiny bit more complicated. And if we zoom in a little bit, we see that, for example, there is recent news about agriculture. If you think about that, recency is not really a semantic attribute. So a text embedding of recent news are not structurally different than text embeddings of older news. Maybe there are different topics, but in general, they should use the same language. They should be quite similar to each other. So if you think about it, the same can be said about, for example, pens for me. Like for me implies that I expect the system to understand my previous behavior, my previous choices in clothes, and it should like recommend pens for me based on those previous choices. So all in all, what we can say is text embeddings are just not enough, and we need more data to properly handle complex queries like this. But let's stay focused and let's keep with numbers. So let's try to think about embedding numbers using text embedding models. I don't know how many of you have tried the take-home exercise we suggested to do in this collab, but I guess if you did it and used some text embedding model, you should see some similar form like this. Because, you know, going back to the presentation, these charts are created using OpenAI text embeddings, which are kind of the best ones, we can say, or the leading ones in some sense. Of course, not in every sense. There are a lot of benchmarks, but like in general, they are considered a pretty good go-to solution. And what you can see here is that number embeddings, cosine similarity to each other is by and large seems fine. So like there is a trend downwards from 50 to 0 and from 50 to 100, but there is way too much noise inside these similarities. So building some application based on semantic similarity on top of these embeddings, I think is quite shaky. I wouldn't go there. I wouldn't be so calm building an application on top of these applications. By the way, embedding, sorry. By the way, feel free to type in the chat which embedding model did you try, if you did, and share your experiences with it. On the other hand, if you see how we embed numbers at Superlinked, you can see a different picture. Like, for example, in these charts, you can see the IBM employee data, which is a quite well-known data set from Kaggle, and it essentially has unique employee data on employees, and the task is to predict if they are leaving or not. But we use that to create embeddings, and the two ways we did that was, first one was what we call LLM embeddings. Is a very simple one. You just stringify all the data. So you do something like job satisfaction equals to comma, some other attribute equals X, comma, and that's your string representing the employee, and you use an LLM to embed that text. That's something that people do in the industry nowadays, to just hoping that the LLM embeddings will somehow make their magic and represent every aspect of the data with this text embedding. On the other hand, what we created are superlinked embeddings. On the right side, you can see that these are tailor-made embeddings for every data modality. We will get deeper into that, how that happens. And I think what's important to notice here is that while on the left, you see quite unorganized blobs where the different levels of job satisfaction, that's one attribute that's in the data, is colored with going from white to blue, are quite scattered around without any clear structure. While on the other hand, on the superlinked embeddings, you can see that all the kind of vertical axes are referring to the same level of job satisfaction. So the structure that is there in the data is also there in the embedding space. But let's not only take that and accept that it's this is the way. You can see that if we color the same data, so the same embeddings based on another attribute of the data, you will see that the kind of horizontal axes are now representing the different levels of the stock option level. So the embeddings do have the aspects of the data represented via their structure in the embedding space, which cannot be really said about the LLM embeddings on the left. Okay, so that's a first intro about embedding numbers. Now let's move on to RAG. Now RAG is essentially a methodology through through which LLMs are creating value for corporations. As of mid-2024, I think that's fair to say, this is the main way corporations are trying to create value through large language models. And what happens here essentially is we have a user who has some query which is said in natural language. We have a framework that somehow constructs a retrieval based on this natural language query and tries to retrieve items from a knowledge base that are relevant to that query. And this is done in order to help the large language model answer the query by trying to constrain the LLM to only answer based on the retrieved facts that are known to be facts and are stored in a vector database. So why is that great? Is that through this we can reduce hallucinations because the answers are going to be grounded in those facts that we retrieve. Of course, it needs to have a smart retrieval so that the context is actually relevant. So that's definitely an important point. So that's one thing. Another thing important here is that using the LLM is essentially making the responses unique to every query so that based on the context, it's tailor-made to the actual query. So everybody feels like they got a very personal response, like a very tailor-made response to their specific query. So that makes it better in contrary to just showing the retrieved documents back to the queries. And also what's really important here is that smart retrieval makes the LLM job much, much easier, and you can save a lot of money here. And actually, we'll try to show you in the webinar that using really smart retrieval can make Llama 2 7 billion parameter version look like GPT-4 if you do retrieval really smart. So this is why Superlinked is focused on the retrieval part. So we are essentially trying to make the retrieval easier and smarter, not just for RAG, but for other use cases as well. And this is how Superlinked works, essentially. So let's start from the bottom. What we do is we have two sources of data. Let's look at this now as another example, just to make it more interesting, right? So this is now an example about online news outlet. So we have two data sources here. We have news, obviously, and we have some other database that stores the click counts on those news articles. So we have some measure of popularity of those articles. And we use this data set and set up our tailor-made encoders that are specific to any data modality. Like we have number encoder for the click counts. We have a time encoder to encode the publication date of the news. We have a category encoder to encode what category the news is in, like business or sports or whatever. And we have a semantic encoder that encodes the text of the news article to have an idea about semantics. And this way we create this multimodal vector of these individual vector parts, concatenated and normalized together, and store them in a vector database. Currently, we have integrations with MongoDB and Redis, but there are many more coming soon, as you can see on the slide. So this happens with our knowledge base. And when a query happens, people ask a question like, I would like to see popular recent news about risk. So currently, what you would do is you would parse this query into the same encoder structure as you did with your knowledge base. So popular would go into the number encoder, meaning that's a high number of popularity. Recent would go into the time encoder, meaning that we would prefer recent news. News will be the category of the thing that I'm looking for, and risk will be a semantic encoder input so that we are looking for articles that are semantically close to the term risk. So currently, we do this by parsing the query ourselves, but we have a feature coming soon, which we call natural language query, by which you will be able to just say what you want in these natural terms, and our system will parse it into the query and will supply you with the results. So that's coming in like 1-2 weeks. I'm really, really, really excited about it. So this will be here soon. So that's kind of the schema of how Superlinked works in terms of the more data sciencey way. And if we zoom out a little bit and look at it more like from an engineering standpoint, Superlinked is basically the vector computer in the middle. So we aim to be the go-to solution to turn your data from any modality, from any source, stored in any vector database of your choosing that's right for your use case, and use that data. So like take the data, vectorize it, store it in the vector database, and also query it, retrieve data from it according to your use case, which can be reg, which can be recommender system, simple semantic search, or analytics as well. Sorry about that. But now, today, we would like to focus on reg. So let's move on and check out how Superlinked does reg. So now the link that I'm clicking, I'm going to put also in the chat so you can follow along. This is a link in our open source repository. Sorry, just moving the chat window away. So this is a link to our open source repository, and what's really cool about these open source repos and GitHub, that you can just, if you switch GitHub in the URL to GitHub to Collab, now you have a Collab notebook of the exact same content. So you can basically work with this, follow along, and do this here. But I will suggest you to just follow me. I will use the JupyterLab interface because on the one hand, I like it more, and on the other hand, I have a pretty beefy machine, so I prefer to use my local resources than Collab ones. But you can also, click around and do it with me. What's important is that we are using Llama 2 here, and in order to use Llama 2, you need some access from Meta, and this is a link to an article that will help you set up that access. It shouldn't be too complicated. But I really suggest now to follow along, and maybe later on you can play around and run it yourself. So I just hit run before this happened, but I'm going to click it again so that you see that I'm not faking this. And it will just run, so we don't have to wait anywhere. So this starts off obviously with the install of the latest Superlink. Then some importing happens, not entirely important. And yeah, here's the data. So I was thinking that instead of looking at this big wall of text at the beginning, which is also intimidating, and I already lost interest, let's look at the data, because we are data people and we like to do that better, right? So yeah, let's look at the data we are working with. So this is an HR policy-based chatbot solution that we are trying to build. We are going to use the retrieval augmented generation methodology. So essentially, what we are going to do is we try to create a chatbot that basically reads all our HR policies and will answer specific user queries based on those documents. For that, we would first need to set up, of course, a smart retrieval system. So this is the data that we have here. Move this here, sorry. So yeah, we have essentially 4 columns. We have an index, that's obviously just an index. We have a body, which is the body of text that the HR policy paragraph contains, like the actual text of the policy. We have a creation date, which is a UTC timestamp, what we will use as recency. And we have a usefulness score, which is a simple ratio of employees finding the actual paragraph useful when prompted to do so. So this is essentially the data that we have. So the text, the creation date, and the usefulness of the text. And we have 3 policy documents that we are going to have to work with. We have an old document that was created somewhere a year ago, which talks about management responsibilities and maternity leave. Because it was created a year ago, it has low recency and it has mid to high usefulness. That's why we needed to create new documents. So we had a project to create a better version of this old document, also amending it with paternity leave. Oops, sorry about that. Didn't want to click. So it does talk about management responsibilities. It also adds about paternal leave, policy paragraphs about paternal leave. It has high recency because it was created like some time ago, but it has very low usefulness in most of the cases, but it is high for paternity leave. So paternity leave is a useful paragraph, but the other paragraphs were not found useful by the employees. This was a project that was not going too well, so obviously we needed a third document that only clears out all the issues about management responsibilities. This is a high recency, high usefulness doc, so it will be the basis of our chatbot. But if you look at the situation closely, we can't just rely on the new one, because we need information on maternity leave and paternity leave as well. So we are going to need the old documents as well. So our job is not that easy. Of course, this is a schematic example. So this is to show situations that can happen in companies when their knowledge base is not that well maintained, or this just happens that there are a lot of documents about a lot of things, and you precisely create a reg chatbot on top of these, so you don't have to cut an order on that whole mess and hoping to create a smart solution to handle all that. So I don't know if you have encountered similar situations like this, but I have when I was doing consultancy, seen not really in order company knowledge bases that could benefit very much from a smart retrieval solution. So yeah, this is the use case that we are trying to solve. Let's see how we can solve that with Superlinked. So first, what you do is you create a typed schema. That's essentially just a typed structure of your data. You have the columns here that you had in the data as well. Body will be a string, obviously, created that is a timestamp. Usefulness will be a float, and ID will be the index, just to know which paragraph are we talking about. We also instantiate that schema, and then we create our spaces. These spaces are the ways Superlinked is giving you control over how you would like to create the vectors on your dataset. Text similarity space, for example, will encode the text using the text embedding model that's here, a quite reasonably sized, pretty useful model is used here. You can do chunking on top of the text if you prefer. We do too already. That's all done under the hood. You will not have to deal with chunks. You will just get back nice results, as you would expect. We also have recency space that's used to encode timestamps. Here, you can set up a recency space using a period time to tell the system what are the notable time periods that you are interested in. We will use now 300 days because there is kind of a 1 year time frame for the whole documents, and we will want to differentiate the old and the new documents. And we have a number space, kind of the center of this talk is how to encode numbers. We are going to use usefulness, and we set it up so that it has a so the lowest one is 0 and the largest possible one value is 1. So this is going to be the range of the space, and we are going to set the mode. And by mode.maximum, we mean that we prefer the higher numbers. Obviously, a higher usefulness number is better. Yeah, so if after we have the spaces set up, so how we would like to represent our data, we can create an index. This is how we group together the spaces. So this is essentially the step. If you remember here, in the way again. So if we go back here, you can see here in the middle that you create vectors from all those encoders and concatenate and normalize them into a multimodal vector. That's actually what we've seen here when creating the index. We have a parser that will parse the data frame. Of course, this is a notebook example to try things out. So we have a CSV file, which we will read into a data frame, and we will parse that data frame into the system. So that's created for experimenting mainly. And we create finally a running app that will be able to handle queries. And we all did that to perform nice queries. So let's see how we set up this query that we are going to fire up. So we have a query that we do on the paragraph index. So what we created here on the embeddings on our data. We have weights. I think that's extremely important and one of one of the main things I would like to emphasize about Superlinked is that you can set up these weights in the index using placeholder parameters. And this is useful because you can run this query later on with different weights without having to re-embed your dataset. You can give additional weight to relevance. You can give more emphasis on recency if you would like to see recent results. And you can do that in no time without having to re-embed anything, thanks to the design decision that was made here. And going on with the query, you also specify that you are going to look for a paragraph. Remember, paragraph is the instantiation of the schema here. And we are going to create the opportunity for us so that we can supply some search query. Of course, this being a RAG solution, people will try to supply some natural language query, and this is going to be handled with this search query parameter. And of course, we will limit the results because we would want to see just a specific number of the best matches. So yeah, going on, let's try and query this system. So we are going to look for the answer to this query. What should management monitor? This is of course tailored so that the management responsibilities documents can answer this query. And yeah, let's first look at the query. So this is how we actually run a query. This is the knowledge-based query we defined up here. And then we can set the parameters that we decided also, like relevance, recency, and usefulness weights were here. So this is when actually running the query, I can set these parameters, and I will set the search query to be this query this text that I just showed you. And we'll limit it to be 10, top n is 10. And see, if we look at the results, oops, I need this here now, yeah. So if we look at the results, what we can see, this is only a relevance-based result. So we don't care if it's new or old, if it's useful or not. We only check if the document is relevant to the query. And what we will see, we have documents from mixed policies. We can judge that based on the date it was created. And what I would like to point the attention to is the ID 23 and 0, respectively. These paragraphs. These are essentially talking about the same thing, but the 23 one is a fresher one, which essentially overrules 0. And there is one slight difference here. 0 says biannual review, and 23 says annual review. So that's the new policy paragraph that we prefer to be in the context, as this overrules the older one. So we would need to adjust the weights so that 23 stays, but 0 goes away from the results. In order to do that, what we will try to do is increase the recency preferences. We would like to prefer more recent results. And as a result, what happens is 23 overtakes 0, as this is a more recent one and contains roughly the same information. So that's a good thing, but we would want to stress this even more. So let's give even more emphasis to recency. Now, well, from 0.1, we moved it up to 0.4, and now 23 is still in the first place, but there is no 0 in the results. So that's good. We removed some outdated information from the results. Okay, but now there is another important thing. We have document 35 here, which seems to be a relevant answer, but people didn't seem to find it very useful. And if you read into the text, you can see that this is not so clearly written. It has job zizzles, it has employee bamboozle. So this was not clearly worded, obviously. This is a document from the kind of failed second attempt on creating HR policies. So we would like to remove these kind of results from the result set as well. And how we can achieve that is giving more weight to usefulness. So in this setup, now we are giving more weight to usefulness, 0.25. For example, these numbers are kind of arbitrary. Different numbers work too. These are just to prove a point. And now we can see that 35 is removed from the result set, and all of the results are from the recent document that is clearing everything out about management responsibilities. Now, this seems all nice and well, but let's think about the other use case. So what if somebody asks about maternity policies or paternity policies? Will we be able to answer those questions with these weights that prefer newer policy documents? So let's try and see. Let's use the same weights as in the previous example, but now change the search query and ask about the maternal leave policy of the company. And yeah, luckily, our results do talk about maternity leave policies. So essentially, in these cases, when the relevancy of the search query is that focused on an issue that only covered in older documents, in these cases, relevance overpowers recency and usefulness. So we did set up the weights in a way that the essential driving force is relevance, but only if the relevant results have differences in terms of recency and usefulness, we will prefer the more recent and more useful terms from our database. So that's good. That's actually what we try to achieve. So these are the weights that we are going to use going forward. So we just created the query that can handle all types of reg questions that can refer to these documents. So now we can move on to the next step of reg. Now we kind of step out of superlinked realms. So we are going to use very basic stuff to just create a reg query and run it. This is now here. This is like nothing. So only basic Python, no packages are used. We are taking this instruction from the Llama docs on how to use it. And then we are going to create a pretty basic reg template by prompting the model to answer the question based on the information that we provide in the context. So we will provide context here, and we will provide the question here. So if you see now the whole query printed, we have the instructions here about being nice and only answer based on the documents and don't lie and everything. Then our specific information here, the context information that are the 5 documents that were retained for the question, what should management monitor? So like these text that you see highlighted here is the same as in here with the final query that we decided to use, the first 5 here. From 0 to 4, this text is the same as the highlighted one here. And now at the end, we ask the question, what should the management monitor? And we signal that we finished instructing you. Dear Llama model, please continue by answering us. And now we set it up here. We use Llama 2's 7 billion model, and of course the chat one, so the one that's trained for chat. And we create a tokenizer and a generation pipeline from it using very simple Hugging Face transformers code. And then we actually call the generation pipeline with the reg query and observe the results. So in the result, we still see our query. Still see our query. This is where our query instructions end. And here is the answer that Llama provided us. So it says, based on the provided context information, management should monitor the following. And here are 6 points that Llama extracted from our provided context. I would like to highlight here the annual policy review. This was the stuff that we looked at earlier when document 23 and 0 had a difference in terms of annual or biannual policy review. We do see annual policy review. So thanks to the clean context, Llama could answer a very structured, a very nice way our query. And I'm pretty adamant to say here that if I've seen GPT-4 answer something like this, I will be pretty content. So again, making retrieval smart can make a small 7 billion parameter model look really good and shine. So yeah, this is the end of this notebook. Just this, I would like to tell you about our open source repository. So we have been looking at the repo here. The reg notebook is inside the notebook folder. There are other notebooks here as well, which are specific to some other use cases. We also have feature notebooks, which are more into explaining one feature of the system in more detail. Yeah, and maybe some other thing that's interesting in the repo is the server folder, which is a very basic framework for you to step out of the notebook boundaries and do a POC using Superlinked. This has some README on how to do it. Don't be intimidated by this lot of text. Some of the points actually just tell you to like CD into a folder, so it shouldn't be any complicated. And this way you can deploy your app even. And just to really quickly show you, I have this code here, which is the same code that we had on the notebook, just tailored a little bit so that it can be run using the server. So you can remember the paragraph schema, you can remember our spaces, you can remember our index and our query. But what's different, obviously, is that we now load the data differently. And we have now a Redis vector database as a backend used. And we have a REST executor, essentially giving us REST API endpoints so that we can call them and do the same querying on top. So yeah, I think that was me. Thank you very much. I hope you could keep up and I didn't lose you in the middle. And I'm open to your questions. And please ask everything you have in mind.
Amazing, Mór. Amazing. I think before we do anything, let's get in the chat and say thanks. Give us a little clapping emoji. Let Mór know that it's been well received. It's been well received. So yeah, love to see it, man. And thanks to everyone for being so interactive as well. We had such a good number of you on there, and it's clearly been, as I say, very well received. So Ben's been doing an absolute stellar job on the back end. Mór, if you go into the Q&A, he's been typing away like a demon. So there's still a few open, which somehow Ben hasn't got to. We needed a Ben AI or something to finish those one off. So we can finish off the ones that Ben's missed, and perhaps even revisit some of the ones that he's typed the answers to if you think they're relevant for any particular talking points, man. So yeah, amazing. So how did you find that, Mór? Were you happy with everything so far?
Yes. I'm looking at the open questions now. And
amazing.
The first one is already interesting, but please go ahead.
Mate, perfect. I think what I'll probably suggest actually is if you go into the Q&A and where it says order by most recent, you can actually order by most upvotes. And again, for the people watching along at home, if you haven't got a specific question, but you like one of the ones that are in there, you can give it a little upvote, and that makes sure we get to the most recent ones first. In terms of that, Mór, are you happy for us to just kind of start at the top there? Question from Bilash and work our way down. Does that make sense?
Yeah, absolutely.
Amazing stuff. So the first question there from Bilash, does it work with some sort of nested importance, i.e. within usefulness, userfulness, it would retrieve with highest recent information? So yeah, could you speak a little bit about that, please?
Yes. So I think if I understand the question correctly, it tries to find out how those different attributes of the data are interacting with each other. And so what happens essentially is that you have these different vector parts, like the usefulness and the recency vector part, and we are able to weight them independently. So we can give weights independently to each other to the vector parts, and via the vector similarity, which is essentially a cosine similarity, which is essentially a dot product, you will have those affect the similarity according to obviously their actual similarity in the data, but that is scaled with the weight that you supply for that data aspect. Was
Amazing.
Yeah, hopefully that's clear.
Amazing, spot on, man, spot on. What I might do actually is I might get you to stop sharing your screen as well, which might also just help people see us a little bit better when we're talking at home. There was definitely a few questions asking for the links to GitHub again, so we've stuck that in there. Anyone heading in there, don't forget to give it a little star. You qualify to enter for the raffle, so we've put a link into how to enter. Win yourself some AirPods. So check that out. Next question's from Charlotte. This may be a bit of a repeat, but let's just double check. So what we're saying with that next question, Mór, do you think that's good to go?
For the usefulness metric, we need to know the question beforehand in order to assess the usefulness of the documents. Is there a possibility to make this metric flexible and usable? Oh yeah, very good point. Very good point. So yeah, it depends on what the query was, if the actual paragraph was useful. So yeah, in this toy data set, I was expecting it to be asked from, so like I was trying to exclude that aspect of like maybe he didn't find it useful because that was not what he's looking for. So that's an imaginary example, but a very good point. Yeah, so good point. But I tried to exclude this complexity from this data set. Yeah.
Amazing. Thanks very much, man. Just as we're chatting there, I've pinged Ben a little direct message. So if you're watching along, Ben, drop me a reply. I'm seeing if we can get Ben and Harshal to come and say a quick hello, but they may not want to, but if they do, they're welcome to jump in because it's a wider team at Superlinked and yeah, great bunch of people. So, okay, next question there at the top from Bojan. I hope I've probably pronounced that really wrong. I'm sorry if I have. Question for the presenter. Could you compare your approach with text-to-SQL approach, and what are the pros and cons?
Hi, yeah, again, a very good question. So I would say that this question boils down to whether you can reflect your preferences better using SQL statements or these kind of vector similarity operations that we do. And I would argue that with vector similarity, you can express your preferences in a more fine-grained way. Like think about, for example, recency in this example. What you could do using SQL would be to like set up a cutoff. Like I would say that only stuff that's at most 1 week old is recent. That you could do using SQL. But what I tried to show in this vector search based approach is that vector search and specifically this dot product based similarity is useful in the sense that you can smoothly blend in preferences in terms of different aspects of the data. So you could blend in relevance, you could blend in usefulness and recency, and try kind of work with that interesting trade-off that those attributes have. So that's not something that you can do in SQL, I think, or I'm just not knowledgeable enough in SQL.
Amazing. Thanks, man. I'm gonna do it. Let's go off piste a little bit and see if Ben fancies jumping in. Harshal as well, if you fancy it. Do you fancy sticking your camera on, Ben? Come and say hello, mate. Your fingers must be tired. I've seen you both, tapping away in the background. So, are you happy with your boy? Has he done a good job so far?
Absolutely. I mean, both Harshal and I, we learned a lot. We actually on the more operations commercial side of the business. So been sweating a bit answering the questions, but also learning, and hopefully everyone else on the webinar.
Same. There's been a good few hundred people learning along with you, actually. So the reason I just wanted you to jump in, Ben, actually, was I had a few questions, less technical, and we'll get to some more of the very technical questions. But having you sat in the background, I was also keen to learn a bit more about Superlinked. As I say, you've been a great supporter of the community for quite a few months, years even now. So yeah, could you just tell us a little bit more about where you're at as a business, what the growth plans are, what people can expect to see from Superlinked in the next few months and years?
Yeah, absolutely. Thank you, David. So we are, recently raised our seed round. We raised 9.5 million from US-based investors, index ventures, serial ventures we're needing, and then a few more smaller funds and a bunch of executives in tech businesses in the Silicon Valley who participated. We are very much building out the product. We are getting into design partnerships with some of the brands that you probably know already, and we have several live deployments as well. I was also mentioning in the chat the e-commerce platform that we launched a couple of months ago, a recommender system solution with, based on the principles that Mór was talking about. We currently operate in London. So London is our basis for the business commercial operations team. Silicon Valley, where my co-founder Daniel is based. Hungary, where Mór is based, with our core platform engineering team. And we have also a team in Israel that is leading on the research and also client-facing projects.
Amazing.
So in terms of where we are now, we just recently launched the server. So basically through our GitHub repo, you can already deploy it on a single node deployment in your own cloud, try it out, feed the real data, connect to Redis database or Mongo database. Those are the two first that we launched. We are now building more connectors. And of course, prioritizing alongside our design partners the different spaces, right? So today we talked about the numeric space. There's lots of interesting other spaces such as graph embeddings and time series embeddings, especially in those kind of financial applications when you want to see a time series of a share price development or development of revenues or P&L of a company. So very exciting times ahead. We are hiring across all locations actually, but again, tech is SF, Israel, and Hungary, and in London, the operations and the go-to-market commercial team, so marketing and sales. So yeah,
Amazing
thank you very
stuff.
much, everyone. Appreciate the questions were awesome. And again, sorry, Mór leaving a few for you. I think they were a little bit above my pay grade. So,
mate, honestly, I'm so pleased for you guys, and you know, congratulations on that seed round. And you know, I'll be watching along with everyone else, seeing where you take it, man. So all the best for the coming months. We have got a bit more time left though, so we've got more here. So I'm gonna keep peppering in with more. But just super quickly before I do, shout out to you as well, Harshil. Thank you very much, man. So have you enjoyed everything from your side so far today?
Absolutely. Thank you, David, and Mór as well for going through that. Thanks for everyone for joining and participating. I think webinars are great way to just engage all around the world. As we've seen, everyone joining from everywhere, and some people that may be watching the recording of this later, feel free to reach out and connect to us as well. We'll be more than happy to go through any more information and any questions you might have after this as well. Thanks, David. Appreciate that.
Amazing. Nice one, man. Nice one. Let's get back to some of these questions then, Mór. We've got the boys in that have been doing the typing, and now we've kicked them out again. So yeah, jumping back to the questions, I've just refreshed in terms of the upvotes. The top question there is from Masood. Masood saying, am I correct to understand the Superlinked sits before vector database? In terms of data ETL journey, legacy data sources turn into embeddings. Basically, can you please elaborate a little bit more in terms of Superlinked and where it sits?
Yeah. I think I might share my screen back because
Thanks, man.
because there's a good slide about this, I think. So yeah, if you look at this slide, essentially yes. So you have your data in various sources on the left, and you would import them into Superlinked, the vector computer, through our executors. You would then vectorize that data using the spaces that we have seen in the notebook that would describe how you would want to vectorize them, and then store them in a vector database. But then Superlinked is also like before the vector database and after the vector database in a sense, because you would also use Superlinked to query your data in the vector database as well, because we extend the functionalities that these vector databases are offering in terms of approximate nearest neighbor search, for example, with the query time weighting and with the dynamic parameters that I've shown in the queries. So in a sense, yes, and in a sense also after the vector databases is, I think, the full answer.
Amazing. Thanks. I love that. Having a slide to hand is always the best way to answer a question, isn't it, as well? Just as you were typing that, Daphne gave us a little shout out. She's had to drop off, but just wanted to say thanks so much more. It was a great session. So yeah, thank you very much, Daphne. Question at the top from Asma. Have you already made some comparison with LangChain and Haystack?
Yes. Obviously, they are very closely related in terms of the semantics that we are doing. I think the main differences are on the one hand are multimodality. So we try to focus more on not just text but other data aspects. So that's, I think, definitely something that is a difference with LangChain. Also, LangChain does a lot of the LLM operation stuff that we are currently not doing. So there is some overlap, but there are also the union is greater than the the intersection, we could say in this case. And yeah, with Haystack, I think it's also quite similar. I would say the difference there also is the multimodality focus that we have, and also maybe I'm not I don't know everything about Haystack, but as I've seen, I think Superlinked is more focused on trying to give a production ready environment and infrastructure as well with its offering.
Amazing, amazing. Thank you. I've given it a little refresh again, and the top question there is from Kenny, which looks to be a great question from Kenny. So Kenny's asking, how are you seeing Superlinked used beyond RAG queries? Could you tell us any more about other use cases?
Absolutely. So our four main areas that we are trying to focus on is of course RAG, analytics, so that basically just use Superlinked to create vectors and use that for your analytics team to understand your data. That's another one. Some, like we could say, simple semantic search, like for example the example I had about news articles would be considered, I think, a simple semantic search use case. And also recommender systems that Ben mentioned that we did for an e-commerce previously, for example. So I think these are the focuses. And you mentioned, the question mentions also the agentic flows. I think that's not something that's in the near future for Superlinked, but as an element in an agentic workflow which does smart retrieval, absolutely. But interacting with LLMs is not our close, like short-term focus right now.
Amazing. Thanks, man. Thanks. Yeah, a couple more people saying thank you. Anna, thank you for the demo. This looks really friendly to use. I'll try and find some time to experiment with it. Liam, thanks. Very informative. Have to go to another meeting, but very enjoyable. Good luck with the rest of the webinar. So yeah, thank you both for giving us a little shout out there. We'll plow on. A question there from Satvik. Could you speak a little bit more in your case? How did you assign the usefulness score to your data?
So in all fairness, this is a generated toy data set. So the real answer is I simulated it. But I would imagine it to be happening via some form popping up for people after trying to use some tool that was designed to interact with the HR policies. That was the imagination.
Sense.
Yeah.
But you are being very efficient there, which is what it's all about, man. So amazing stuff. In terms of next question, jumped up to the top there from Philippa. So thank you for your question, Philippa. How do you go about evals and checking the outputs are reliable? Is it always manual?
Excellent question again. So on the one hand, if you are lucky enough to have labels, you can do information retrieval type of evals like NDCG or MRR or this type of metrics you could monitor if you have labels. If you don't have, though, which were the case in most of the cases that we have been facing, I think the thing you can do is A/B testing, and A/B testing live with users. I think
makes a lot of sense. Makes a lot of sense, Mór. Thank you, man. We've got a specific question about Superlinked from Bilash. How is sensitive data is managed by Superlinked? So could you perhaps speak just a little bit more to how Superlinked structured? Tell people a little bit more. I feel like a lot of people watching this are going to want to get involved. So the more you can tell us, the better, if that's all right.
Yeah, so one design decision I think that we made when creating Superlinked was that we are not trying to create an all-around data platform, and I think that's a decision people should make, because you can't grasp all the field. And yeah, one thing that was cut from the scope is kind of data preparation, data cleaning, and I would consider hiding sensitive information or masking out PID as one of these. So we generally don't do this. So we don't deal with this. So you would have to do it yourself before using Superlinked.
Amazing. Yeah, makes sense. Makes sense. Again, question from Masood, which is specific again about Superlinked. Can you please tell us a bit more about which vector databases Superlinked natively supports?
Yeah, absolutely. So we have an in-memory implementation that you have seen me using in the example, which you can experiment with in the notebook. It's really lightweight. It's essentially an NumPy array. But we also have connectors for like real life use cases. One of them that we already have ready is Redis, and the other that we have ready is MongoDB. And we are closing in a few others that I'm not in the liberty to disclose, but we are creating connectors as we speak, mainly based on user requests. So we kind of prioritize based on how many people tell us that they would use us if we would have a X connector or a Y connector.
Amazing. Yeah, makes a lot of sense too, man. Makes a lot of sense too. I'm a little bit conscious of time with some of these webinars. As you may see, people slowly start to drop off and head to their meetings, and we're getting about to that sort of 2 o'clock time, UK time, but it is potentially getting to that time where people are dropping off to different meetings and stuff like that. And what I'd say is, you guys have smashed through 17 questions, which is possibly some sort of record. So amazing effort from Superlinked. And there is sadly 5 questions that we haven't had time to get to, but what we could potentially do is take those questions plus those already answered and maybe turn it into some sort of blog post or something like that, which may be interesting to share with the community and go from there. I'm just going to finish by saying massive thank you to yourself, Mór, first and foremost. I say at most webinars, but when you come and present these sessions, it's not just the time that you've given up to present, it is also the preparation time. I know we were chatting behind the scenes beforehand and you were saying how much you've been, practicing, getting it all ready and stuff like that. So, massive thank you to you specifically. Ben and Harshil, thank you again for being part of it in the back end. But beyond that, actually, again, specific shout out for you, Ben. As I've mentioned before, you've been a big community advocate for a long time. And with the Data Science Festival, everything we do is always free. We've got our October conference coming up. It's expensive to run these things, so having people like Ben and the whole team at Superlinked keen to support is massive. And what I would say is, go do check it out. As I say, I feel like big things are coming with the team at Superlinked, certainly in a very exciting space. So I look forward to seeing what you do with this seed money and then where the Series A and the Series B and, you guys will all be billionaires next time I see you or something like that, which would be cool, isn't it, man? So awesome. I'm going to hand over last word to you, Mór. How did you find it? Were you happy? Have you got any final comments before we draw things to a close?
I loved it, David. Actually, I was really nervous. I couldn't confess now, starting the whole thing. But you were a lovely host, and people were lovely to me as well. And I love the questions specifically. So this is a great experience. I would love to reminisce about later.
It's funny, isn't it? Sometimes you're online and you're just like, oh, I'm online and stuff like that, but it still feels like a community. And, thank you to everyone that's joined, has been so interactive in the chat. And I'll finish with a couple of final shout outs from there. So yeah, Bogdan, man, they're coming in too fast. They're scrolling too far. Great webinar. Very interesting as usual from Superlinked. So that they know you're there. So we love that. And thanks for the session. Good luck with everything. Thanks so much for the prep and answering the questions. Daniel, great presenter. I will echo that one, Daniel, man. So thanks so much. Abhishek, thanks. It was wonderful. You did very good. They're coming and coming. So I will draw things to a close there. But yeah, thank you to everyone that's joined. Check us out. We've got more stuff coming up. And massive thanks to Superlinked. And we'll see you all soon. Have a good day. Speak to you a bit.